Hi guys, in this video I'll be going deep into my experience using the new DPVR E4, relating all my findings under one video and putting my own spin on a review. As primarily a PCVR player and a bit of a DisplayPort snob, the DPVR E4 has been on my radar for a while, being a lightweight dedicated PCVR headset with claims such as great stereo overlap, great visuals, and 120Hz on DisplayPort cable, all for sub £500 in the UK. It certainly piqued my interest. Ordering from DPVR directly, the order was sent direct from a UK warehouse, arriving the next working day for me in the UK. Unfortunately for me, the sun also decided to make an appearance, being the sort of temperature that I typically avoid playing VR in. And while this video is a little late for the YouTube bandwagon, I do not have any affiliation with DPVR, having to wait and purchase my device just like everyone else. As such, I'll be completely open and truthful about my experience, with every day spent using the device, discovering and learning something new. This video will be chaptered, so you can jump to any specific area you're interested in. Now that's all been said, let's dig into this thing. Hardware and first impressions. First we have the headset itself, being a pretty sleek, tried and tested Halo headband plus 4 inside-out camera arrangement. Anyone coming from Rift S will feel right at home here. The visor design has a holographic midsection and configurable RGB that shines through its centre, with the matte white plastic being used throughout having a soft touch rubberized finish, with only the microphone holes on the bottom of the visor breaking up that otherwise sealed design. No extra buttons or ports are present here. The faceplate being a soft flexible silicone intended to remove the pressure against your face, which for me is an issue I'll cover later in the video. The DPVR E4 uses Fresnel lenses at a fixed IPD of 64mm, no more, no less, with the only IPD adjustment being available through software. One interesting feature of the headset is the ability to very quickly flip up the visor so you can see your surroundings, the hinge mechanism firmly holding the visor in place when it goes up and down at a singular point in the centre of the halo. The hinge does not offer any adjustments between that, so you cannot change any distance to the lenses or tilt the visor without adjusting the fit of the head strap itself. The built-in speakers can be found on the underside of the halo band, which while terrible, they are at least present, and while you do have a detachable DisplayPort cable, it's not the full length to the headset, leaving a very short length on the head strap itself, unable to be removed. There are 2 strain relief clips that come pre-installed, the first side clip being a predetermined location so it gives you enough slack to accommodate the full hinge movement, and the rear clip that allows full range of headband adjustment, although this does mean your cable protrudes from the sides, with it being more pronounced the tighter the head strap is, something to note for storing a headset or wearing over-the-ear headphones. Dangling at the end of the cable is a tic-tac sized box DPVR cooler hub. I'll also reference this as a cable hub throughout the video. The hub having a recessed Oculink standard cable connection and a 3.5mm headphone jack. More on this headphone jack in the audio section. For fitment and comfort, there is a stretchy rubber top strap that will conform to your head and suspend some of the weight of the headset. The front, sides and back padding are all removable via Velcro fasteners, allowing easy comfort changes and further head size adjustments. The rear tighten dial is the recessed design, which feels good and smooth to adjust. But this rear cable clip can sometimes unfortunately leave the DisplayPort cable in the way when wanting to adjust the dial. So now we have the DisplayPort cable itself. On the PC side, you'll have a single USB 3 Type A and a full-size DisplayPort connection, along with another hub box that has a 12V power connection. At the headset side, we have a male Oculink connection that goes into the cable hub and locks with thumb screws. This cable is pretty thick and heavy, not being able to flex easily and occasionally put an upwards pressure on the halo band itself when I've been switching from standing to seated play. A cable clip is supplied here to hold the cable to your shirt and keep the cable path running down directly behind your back. I would like to see a more flexible fibre optic cable offered here, as the one supplied feels unnecessarily bulky, measuring a little over 4 meters. Also included is a 12V 2A power adapter, measuring 3 meters long. This power adapter covers different regions via swappable ends to the adapter. While specs of the headset suggest it is light, with the weight intended to be distributed across your forehead, it somehow still feels heavy for me, no doubt in part due to that heavy cable. Using my own scales for comparison, the DPVR E4 is shown here weighing at 1.2 pounds or 0.54 kilograms without the cable, and a whopping 1.9 pounds or 0.86 kilograms with its full cable length. Controllers and tracking. The controller material build quality seems fine, with no creaks or squeaks in normal handling. Having the traditional VR control layout you'll be very familiar with if coming from an Oculus headset. The joysticks here, something I don't think I've seen on a VR controller before. They are very low profile with short travel. Sneaking up on enemies with these joysticks is going to be a challenge due to the lack of travel. They require a single AA battery per controller, which are not included, with these controllers weighing just 0.55 pounds or 0.24 kilograms for the pair with the batteries I'm using. The handles are very similar to an Oculus Rift CV1 controller, being only marginally longer, with the same angle of tracking ring too, but mounted on the top side for the inside-out tracking. Controller tracking has been more than respectable in my testing. Controller occlusion will show the typical inside-out tracking limitations, but this is not specific to this headset, and it has fast recovery when it can see the controller. The controller tracking volume is also good here, and overall the tracking is comparable to my other inside-out tracking headsets. Further adding to the drawbacks on these controllers, however, is the lack of capacitive touch, so you will not be able to emote with hand gestures such as pointing or giving a thumbs up, with some titles even requiring a thumbstick rebind within SteamVR. There is also minimal travel on the triggers. While the physical motion can be made smoothly, they don't have sufficient resolution to report to SteamVR as a linear movement, losing that fine control and reflecting as unnatural animations to your game hands. And as of this review, when using the DPVR controller models in SteamVR, I am unable to scroll through the SteamVR overlay when using the thumbsticks. This can be easily corrected by an update and temporarily works around using the joystick controller option within the DPVR Assistant software. Another big drawback on the controllers is the haptics. They are very scratchy and underpowered compared to my other headsets, with no way to increase their strength in the software. Controller battery life seems good so far, but I don't know if they'll be able to match something like the Quest 2 just yet. One thing that could be a potential killer of battery life, however, is that any motion will cause them to wake and search for the headset, regardless of the PC software being open or headset even plugged in. While this makes it faster grab and go wanting to get into VR, it's something you are unable to stop happening without removing the batteries themselves from the controllers. This is something that can easily be addressed with the software update. Pass-through and room setup. Although the headset has a quick to flip up visor design, there is still an option of a black and white pass-through offered here. This is primarily used for your playspace setup and painting your boundary outline on the floor, which has been very reliable for me, not having to redraw my boundary since doing that first setup. You can configure a double tap of the DPVR key on the right controller to go instantly in and out of pass-through while inside SteamVR, although the image does have a very noticeable static texture over the whole image, giving a dirty window effect to the pass-through I've not seen in my other headsets. Another thing noticed in faster head movements is that it would be a render of your game just in the outer side of your vision. Presumably this is because the pass-through is activating a layer to the video feed. Pass-through will not pause the game or disconnect anything from SteamVR. All audio, tracking and controller inputs still work. Activation in and out of this pass-through is immediate, and much faster than that on any of my other headsets. So while not strictly necessary due to the visor's flip-up design, having it does save disturbing the headset position for those moments you only need a couple of seconds to see, and will switch to pass-through when you step out your boundary, and works well enough for that purpose. DPVR E4 Assistant. As of review, the software version for DPVR Assistant is 4.1.5.29. The software installation and hardware setup for the DPVR is very straightforward. On first setup, the software does present a login screen, offering sign-in via Facebook, WeChat or email, but it also has a visitor mode. While I'm unable to say what difference it is if you log in, I can thankfully say that using the visitor mode has no loss of functionality. I have not seen this screen since first setup, but you can get back to it by logging out if you should change your mind. The software setup and room calibration is the best I've ever seen in VR, with simple to understand UI and a voice talking to you throughout the process. If you do something wrong like not completing a full boundary, it will let you know both visually and audibly. This process is incredibly fast and really impressive. If for whatever reason you need to run the hardware or room setup again, you can access these options in the top left hamburger menu. While installation was a breeze and the software is incredibly intuitive to use, I did hit a hurdle the very first time I wanted to use the headset, in that I could simply not get past the first room setup. Taking the headset off and checking the PC, a message was already on the screen to show a firmware update was available to download. After doing this update, it's been incredibly simple, fast and reliable getting into VR with this headset. There is still some options missing for the advanced users, but I've already found some hidden goodies within the driver files, and I'll put these in the more relevant SteamVR section of this video. While the software is relatively lightweight and shouldn't be a problem for any VR capable gaming PC, it doesn't come for free, showing 10% CPU usage just in Windows on my Intel 12700K. So nothing really to worry about, but worth a mention. The headset is reporting as driver direct mode to SteamVR, so while this is a DisplayPort cable headset, it is not fully direct to SteamVR, requiring some compositor overhead. As such, the DPVR software is required to be running at all times to display an image to SteamVR. And at the time of review, the screen panel backlight is activated when the software is open, even when the proximity checker on the headset is not covered, something that could be addressed with an update. Closing the main assistant window will put it down into your system tray, but not exit the app or turn off the backlight. Only until it is exited from the system tray will the panel backlight turn off. So as of this review, I would avoid using the auto start with Windows option. This issue plays into something I will cover in the call-in section of this review. On my system, the software uses the graphics card's NVIDIA high-definition audio for the headset sound, and has been reliably switching to playback devices in Windows. I am unable to test with an AMD GPU, but I would imagine this is much the same. After installation, the default value for the brightness here is a very low value, given a very dark image in the headset. Thankfully, there is a brightness slider to adjust this. You also have the option to set refresh rates of 72, 90 and 120 Hz. There is also a software IPD adjustment tool to adjust the IPD anywhere from 50mm to 80mm. This is purely software correction and will not adjust the lenses at their fixed 64mm IPD. In the controller section you'll find options to select which controller models are used in SteamVR. Standard being the DPVR controller models, and the joystick and touchpad options being the Oculus Rift and HTC Vive ones respectively. These two additional options being offered for certain game compatibility. As covered in the controller section of this review, currently the DPVR controller model option has broken bindings to SteamVR, so using the joystick controller option here is a workaround until a new update becomes available. There are also options to enable the recentering and pass-through shortcuts via the controllers. Included in the software is a media player. Launch into the SteamVR app to play back all different sorts of formats for the videos you have saved on your PC. Playback is shown on a big virtual screen in a void environment, with the player having a pretty basic but easy to understand UI. This works pretty well and is a nice touch to be included with the software. Overall, DPVR has done a fantastic job with the software experience, making it simple to understand and easy to use. I have to end the software praise with a warning about the hardware tying at the time of review. I suggest only connecting the Oculink connection to the headset at the point you're ready to play, and disconnecting directly after use. I'll go into more of this in the cooling section of this review. DisplayPort and SteamVR. The DPVR Assistant is always required to reproduce an image to SteamVR, so this is not a full direct to SteamVR headset over the DisplayPort cable, leaving the DPVR Assistant to call all the shots, with leaving you with only the basic options to set your refresh rate presented to SteamVR. Once in SteamVR, manually changing the global render resolution will also require a SteamVR restart to take effect, which is pretty normal behavior. So why have I mentioned this?
Oh shit, here we go again.
As of this recording, the resolution reported to SteamVR for its 100% render is 1800 by 1800 per eye, an equal height and width render for a panel that is not equal width and height in its resolution. Now I'm not too worried about how they're doing the viewport size to SteamVR, but the render resolution value for 100% is way too low. That said, you'll likely not notice anything wrong when first fitting the headset, as the SteamVR Void, the SteamVR overlay, its media player and IPD adjustment tool, and generally anything close to you, is initially fine. However, in games, this looks terrible at 100%, and it's just one part of the contributing factor to people receiving these devices feeling as if they see compression, which should not happen on a DisplayPort cable headset. While some reviews are claiming the visuals look great, I can only assume they're using SteamVR's auto resolution, which has a maximum clamp value of 150% SteamVR render resolution. This is not super sampling in the actual sense yet, as the starting point at 100 is certainly not representing a true one-to-one image factoring in the correction for lenses. So while this can easily be addressed or worked around by using a SteamVR render resolution slider, there is no way to adjust the baseline 100% value from within the DPVR Assistant software, like you can with Oculus Link. By having a poke around in the drivers, I have found a means to adjust this, although as expected, forcing anything other than a square ratio will break the image to SteamVR, as can be seen here using the Quest 2 render resolution. So best to stick to adding a multiplier to the default resolution. So now we have two means of adjusting resolution to what I would call a respectable DisplayPort image. This is sadly not the only thing that people meant when they said they could see compression. I really don't know what is causing this, but I suspect it to be a compositor problem. Changing resolutions and refresh rates do not change this behavior. Further to this, I also need to mention the distortion with this headset right now, again being visible in a SteamVR mirror window, as shown on the windows of the building in Half-Life Alyx, with the upper part of your vision through lenses being worse affected. Another issue I've come up against in SteamVR is using the SteamVR FOV slider. This completely breaks the image in headset. The FOV slider is causing a shift in vision overlap that I've never seen before, operating nothing like it's supposed to. And on a lesser note, the DPVR controller models in SteamVR are bright white, which is an unfortunate choice when looking through the lenses, as these cause pretty bad God rays in the SteamVR Void environment. This can be worked around until an update becomes available to address this, but for now, you can edit the controller model skins yourself using the file and location on screen now. Screen. The LCD panel used here is a physical resolution of 3664 by 1920, or 1832 by 1920 per eye, and has very little screen door effect. It offers refresh rates of 72Hz, 90Hz and 120Hz, with the panel's overall brightness and colours similar to a Quest 2 and Pico Near 3 Link that I have here. It's a respectable image and I don't think anyone would be unhappy about it. On first setup, the image is incredibly dark, but there is a brightness slider giving it 0 to 100% control of the LCD backlight. You can make this much darker than any other headset, essentially turning off the backlight completely to see nothing at all. My unit did not have any dead pixels, mural or anything untoward. The only difference I can see is because of the lenses. Lenses. The lenses here are not adjustable, being a fixed IPD of 64mm, with any software IPD adjustment offered. I'm unable to tell you how the headset looks outside of its sweet spots, being that my IPD is perfectly matched for this headset. As like with some other Fresnel lenses, they do not allow much movement outside the sweet spots before things become blurry, but the sweet spots on these lenses are marginally bigger here when compared to something like a Quest 2. The size, shape and profile of these lenses are similar to that of the Oculus Rift CV1, as shown here fitting prescription lenses from my CV1 onto the DPVR E4. Due to the tapered plastics underneath the lenses, I'm unable to make these stay in place. So while similar dimensions to the CV1, they are not the same lenses. Edge-to-edge clarity is good here, being much better than that found on the Quest 2, and more in line with my Oculus CV1 and Pico Near 3 Link headsets. This edge-to-edge clarity also lends itself into a great stereo overlap and increased horizontal field of view, meaning you will need to force yourself to go cross-eyed to even realise there is a divide between the lenses, and you don't feel like you're looking through two tubes. This makes it feel very open and spacious when viewing through the lenses, being a fairly big difference compared to what is found on the Quest 2. While my other headsets, the FOV values are entirely dependent on my distance to the lenses, this is not the case with the DPVR E4, as I'm unable to really change that due to the design. In render, the DPVR actually has less FOV than my other headsets, but let me explain why this headset feels so much better and why the FOV value itself doesn't tell the full story. With a Quest 2 for example, the rendered FOV is actually more than the DPVR for both the vertical and horizontal, but the smaller lenses, worse edge-to-edge clarity, stereo overlap and horizontal field of view all add up to feeling boxed in with not much room to move your eyes before things get blurry, and have an effect of looking through two tubes. On the DPVR E4, however, the combination of great stereo overlap, good edge-to-edge clarity, and bigger lenses with a good horizontal field of view add up to the DPVR E4 feeling like a big FOV headset, without that effect of looking through two tubes. Although this very spacious feeling is great, you don't actually see any more of the game world, being limited by the render FOV itself. As such, it slots into my previous results just above my Quest 2 with how I wear both headsets. But once again, this doesn't tell the full story, as the diagonal FOV is actually better with the DPVR. I'm aware my previous tests have the wrong FOV numbers, but the positions of the headsets in testing do not change when corrected. For those wanting a true value to base on, I am measuring 90 degrees vertically and 92 degrees horizontally with the correct testing tool. This value doesn't now mean the headset is in last place for my comparison, only that the reported figures have changed, and as covered, numbers alone really don't tell the full story of how this looks through the lenses. Chromatic aberration. I don't think people have any real complaints here, or even notice at all in some cases. The chromatic aberration is only in the outer area of the lenses, that by comparison, completely blurry in a headset such as the Quest 2. This I've learned is not really the failing of the lens correction, but rather the price to pay for good edge-to-edge clarity on Fresnel lenses, as I also find on my pico near-free link when using it in its display port mode. As for glare and God rays, unfortunately this is what lets everything else down on an otherwise great set of Fresnel lenses. Using the provided silicon faceplate, the glare is the worst of any headset I've ever seen. But this isn't fair to the lenses and is entirely the fault of the faceplate. So to get a better understanding of how these lenses look, I have fashioned an Oculus Go fitted facial interface onto the DPVR E4. While this certainly isn't a modification I'd recommend, it does at least provide a better seal to my face. So the following is all based upon a situation with no light leakage from a faceplate change that fits my face shape. The God rays when compared to a Quest 2 are unfortunately worse here, but not really as bad as my Oculus Rift CV1. With that being a pretty big gap between how those two headsets look, I'd have to say it's around midway if you were to have some sort of imaginary line of quality between them. You can mitigate the worst of these in high contrast situations by lowering your brightness and modifying the controller skins in SteamVR, but even when sacrificing the brightness of the display, you cannot improve the God rays enough to be comparable to a Quest 2. In general gaming, unless you are playing something with high contrast or bright white objects or text, you will likely not care given the other things these lenses do well. But I have to reiterate, this is only after changing to a sealed faceplate. Using a standard faceplate, the light leakage is causing additional glare on the lenses and seriously hurts this image. Faceplate. As mentioned throughout the review, the soft silicon faceplate for me is borderline unusable. While it does not leave any pressure marks due to the nature of the Halo head strap, it also means there is no real way for me to conform it to my face shape, causing the most light leak of any headset I've ever owned or tested. It's a fairly wide and flat profile, which for me, leaves the temples and cheeks completely open for light to come in. Also having an annoying issue of it rolling up upon itself as you flip the visor back down. This is made worse still if using glasses, which when wearing glasses, makes a seal on the size of the faceplate even worse for me. Safely wearing glasses with this headset is going to depend entirely on your face shape and the size of your glasses, given the fixed distance to these lenses. For me, I'd need to install a thicker forehead pad onto the Halo to create more space for my glasses, but then this would amplify the issue of light leak from the faceplate, requiring a glasses spacer to be used. Both required changes do not come with the headset. Based on already existing feedback for the silicon faceplate though, DPVR will be offering a more traditional magnetically attached faceplate for purchase. Sound. The inclusion of audio here seems like a complete afterthought. Sound is possibly the worst of any VR headset I've ever tried, with low volume, tinny sound and no bass. There is a 3.5mm headphone jack on the cable's hub box, allowing use of headphones and other audio solutions. Unfortunately, when using the 3.5mm port, I have signal interference that will increase with the volume depending on what screen brightness setting is used. The higher the brightness setting of the panel, the louder this noise becomes. While this could be down to my home's electrical wiring, it could also be the headset itself, requiring to use an inline ground loop isolator to remove noise. This leads me into the missing microphone functionality of the 3.5mm port. Be it through the port or audio drivers being used, I am unable to use any microphones other than the headset itself, which even if it was working, would leave me unable to use a ground loop isolator to fix the interference. Adding to the disappointment is with all my headphones here, the fan noise from the headset itself will still come through into my headphones when no audio or low volume is playing. with my fully sealed headphones transferring the fan vibrations through into the audio. You'll likely need to wear earbuds here, which DPVR were planning to add into future purchases. I've not received these, so I'm unable to comment on their quality. With that said, the tuning of the fan could change, but I can only relay my experience right now. As for the microphone recording quality, I'll let you decide, although I will say this can change with updates that come after the review. This is a test of the DPVR E4 microphone. I'm unable to use my own microphone on the 3.5mm audio jack on the hub box. It does not support microphone. In the moment of silence, you should be able to hear the fan noise produced from the headset itself. At this RPM, you cannot block this fan noise because it will transfer through the head strap itself into your cans, and it rules out any off-ear audio solutions and any open back headphones. At this RPM speed of the fan, it must be this temperature. When I turn my head like this, you can quite clearly tell in the recording that I've either got a problem with this internal fan, or the fan at this RPM that needs to keep this headset cool cannot deal with motion. As can be heard in the recording, the fan speed is extremely audible for me, which could be tuned through both noise cancellation on the microphone and the fan speed itself, with the latter being something that we'll dive into now. Cooling. In a direct-to-PC headset, there is no onboard CPU or GPU to cool, but the heat from the panel itself and the driver board for it certainly needs cooling, especially at 120Hz and full brightness. So the DPVR E4 does have an internal fan. Despite this, for me, the headset gets really hot, much hotter to the touch than any of my other headsets here, and seems to be nothing I can do about it. Given the benefit of the doubt due to some very minor damage to the package from shipping, I contacted DPVR's excellent support, who agreed the fan rubbing noise is not normal, and that it is possibly damaged in transit. So while I will still relay my findings here, I have to state I may have just been unlucky with this issue twice, receiving a replacement headset that is not visually damaged by shipping within 2 working days of my initial email. Truly excellent support, but unfortunately suffering all the same points covered throughout the review and still having the behaviour of heat build-up and fan rubbing noise in head movements. For me in the UK right now, it's anywhere from 28 degrees Celsius room temperature with no air conditioning or climate control before I start using this headset, so not entirely favourable conditions for VR in general. Factors that determine a temperature that is deemed uncomfortable and how long it takes to get there will vary from person to person, so this is all based upon my own experience and my own comfort levels and my own play-space conditions. Having a closer look at the design of the headset again, it's clear that there is absolutely no venting, slots or any small gaps for airflow in and out of the headset itself, at least not in any meaningful way that I can see. This itself could be a contributing factor to what I would go into from here on, even though the devices could be faulty. Upon day one, it was clear that running 90% brightness and 120Hz mode was not something I could comfortably do for any length of time, and while the design can seemingly deal with the heat, my face cannot. Testing across all different brightness and refresh rate levels, I continue to get to uncomfortable levels, with lower refresh rates and brightness only prolonging the time it takes for me to get there. This was cutting my session short and generally put a huge damper on my experience. The first cause of the heat build-up I examined was simply by connecting the cables. In around an hour at my starting 28 degrees Celsius room temperature, this was enough to warm the device so it just started kicking in its fan. No software has been opened yet, and the panel is not illuminated. Upon launching software, the backlight will enable and stay enabled for as long as the service is running, completely ignoring the proximity checker until you're using Steam VR. This is something that could be fixed in an update, but at the time of review, using the software's auto start and Windows option accelerates the heat build-up for me before use, leaving the panel backlight burning at whatever brightness setting was set. Closing the Assistant window does not currently exit the app or turn off the backlight. This only puts it down into the system tray, which you'll need to right-click and exit. Again, this could be addressed in an update. When the software is fully closed, the headset will continue running the fan, but both my units could not bring the temperature back down, instead having a never-ending recirculation of hot air and the constant heat of whatever is causing the draw of power when plugged in. A hot plastic visor not directly touching the face due to the soft silicone faceplate and halo design seems like a happy accident to at least allow some play right now, but the radiated heat over time, for me at least, became just too much. While my room conditions are not favourable to start with, I do not experience anything like this heat build-up across any of my other headsets here. I would hope at least in part that this could be addressed through firmware, only receiving voltage when the software is open and only enabling the backlight when Steam VR initializes to avoid that preheating. Personally, I believe even with the software and firmware changes, this headset could really do with some venting and better fan intakes, for both helping in use and the ability to cool itself down. Closing thoughts. The DPVR E4 is yet another headset of potential, having the idea in place and the best intentions, but falling short on several aspects we all take for granted now. Software-wise, it's clear DPVR have that covered, being the most intuitive software experience I've ever had in VR, with updates that can only improve the device over time and hopefully correct some issues pointed out in this review. Things such as the controllers and the functionality, faceplate, audio and cable all put on a huge damper on the experience, even for those lucky enough to have the perfectly matched IPD. And while there are smaller things I would like to see addressed, the biggest deal breaker for me is how hot the devices I received were becoming in use. Be that through firmware or voltage issues right now, or just being incredibly unlucky with 2 faulty headsets. I would like to see some consideration of cooling into the design for future headsets, given how demanded 120Hz and max brightness will be on the panel. With the sense of freedom these lenses offer, with the great stereo overlap, edge-to-edge clarity and horizontal field of view, it's all incredibly refreshing to see this in a new headset, and something you really need to experience for yourself to understand. But sadly, that alone cannot make up for the trade-offs you have to accept in other areas for general use. With DPVR now having distribution in the UK, I seriously hope they stick around and come back swinging next time, and taking all existing feedback on board for improvements in areas people need and expect when buying a headset. This will make my life much easier for next time. Cheers guys, and thank you very much for watching.
This is fine.